All right, everyone. Well, in the interest of keeping this short and succinct, we will go ahead and get started. Again, if you have questions or comments, please put them in the chat as we move along. So, this is an unexpected part 4 to our machine learning and SHAP coffee break series. And the reason is we generated some testable hypotheses at the end of part 3. And I wanted to show you how we went about testing those hypotheses, specifically on the DNA nexus system. But, as with all of our webinars, you could do this yourself on the command line if you wanted to go through that kind of agony. All right, so let me just hop in. I'm going to do a 2 or 3 minute recap of what we've done before. So my name is Ben Busby, and I drink a fair amount of coffee. And so this is a picture next to my stove of a Chemex and a coffee roaster. I also am proud to have parafilm in my home. If you've ever done bench work, you probably know what that is. All right, so yeah, I'm very interested in complex etiologies, and as actually I'll point out a number of times towards the end of this coffee break, I think really for so many phenotypes, there are lots and lots of different etiological classes, and so I'm really excited to tell you about some of the things we found there, particularly with adverse drug responses. And before I get into this, I'd really like to thank Nick Giangreco and Xiaofeng Lin. Really for doing lots of work and really keeping up an exciting scientific dialogue the whole time we've been working. Great. So at DNA Nexus, we have an exciting tool that does phenotype-genotype integration called Apollo. You can check that out at this YouTube link if you want. And we can send that to you if you're interested. Basically, it lets you do cohort selection on the fly. This is demonstrated here with a 50,000 person synthetic data set. We did this for the entire UK Biobank cohort of over 500,000 people and pulled out lots and lots of folks who had adverse drug responses. 235,592 to be specific. And then we took an approach called light GBM, which will deal with sparse phenotypes and cluster them, and we use that in order to look at this and really think about features that were important for ADR. But more importantly, then we were really able to tune those models and make things explainable. And I think it's really important to note that in these complex etiologies that I alluded to before, sometimes you have penetrant genotypes, sometimes you have complex genotypes, sometimes you have exposures, but it is not uncommon to have all of them. And I think that's certainly what we're seeing in ADR, and that's something that we really found in this sort of part 4 testable hypothesis part. So that's great. So one thing that we found is that if we allow for more classes rather than doing sort of a binary assessment, we see that our AUC is much better. And that's something one would expect with multiple etiologies. And then we're able to sort of explain some of these subclasses. And there's some really sort of like vague and tenuous associations, and I really want to address that later. I won't belabor that point right now, but I think it'll be very interesting to start digging into later. And so we found some very clear associations in terms of how many drugs people are taking and general lifestyle things, in terms of associations with ADR. But we also saw some that were a little bit confusing, and one particularly was the platelet distribution width. And we can see that SHAP values seem to pertain to specific groups of individuals. So I'm, of course, referring to this plot over here on the right with what seem to be clusters of individuals with different platelet distribution widths. And so this gave us the hypothesis that really low platelet count may be predisposing to people to ADR. And so that was a hypothesis that we were able to test. And I am excited to say, actually, that our hypothesis was most likely wrong, and it was probably the inverse, which was an exciting thing to find. And we also see we seem to have different groups. I'll come back to that later. But one thing we found is that there are lots of drugs that actually that actually increase the propensity for ITP, and that being sort of an ADR event in and of itself. And you probably probably recognize some of the very, very common drugs here. So what we did was we went into this graph more specifically with individuals, actually, and started looking with adverse drug response, and started looking at what drugs they were taking. So we were able to do that really in Jupyter notebooks, and that was really nice, and it was fairly straightforward to get SHAP values for individuals, excuse me. But we were able to see this as a distribution of particular diagnoses. So here we could see a whole bunch of diagnoses, and this may become important later, and their correlation with ADR, and looking at this significance. But what I think is more immediately exciting, although again, we'll come back to this later, is that we were also able to look at particular medications and their significance in terms of platelet count. And one thing that you can clearly see here is that simvastatin is right up at the top of this list. And we can go back and see that ibuprofen is a major cause of drug-induced ITP. So the really nice thing is, working backwards, we're really able to predict drugs that predispose folks to ITP in a massive data set with literally millions of fields of phenotypic data. So this is something that I think really has a lot of promise. And this is for sort of really sort of large scale things. But the next slide, I want to show you a really specific result we found. And this is really interesting to me as we sort of move into the era of real world evidence. And that is thinking about something called Bellacarb tablets. And Bellacarb tablets really have very a very strong effect on ADR in a very small proportion of individuals. And so it turns out that folks that take belladonna, which is a major component of Bellacarb, between 1% and 2% of them report ITP. And that to me is extremely interesting, because really what you're getting, you're able to see on our graphs an extremely rare side effect of a relatively common compound that people are taking. And so for being able to predict who will be susceptible to these particular compounds, I think the UK Biobank data set and other data sets like it may be very useful. And that's something that is really, really interesting and really exciting to me. Moreover, we also looked at this sort of biphasic distribution and thought about how people with higher platelet counts are sort of less likely to develop ADR, sort of thinking about things in the other direction, whereas people with sort of a baseline low platelet count have a wider range of SHAP values. Now, as we've shown, some of these folks are actually, it is a matter of drug-induced low count due to those that But there are also folks in this region who probably have low platelet count due to a variety of lifestyle factors. And that's something we've just been able to start looking at. And I really think that has some, if not direct pharmacological consequences, thinking about some consequences when we think about public health data. And that's pretty exciting. So here we're able to think about things like age, BMI, blood pressure, so on and so forth. Those really sort of global features where we're able to see things. And here, just to give you an example, we see sort of different ranks in terms of platelet distribution with for length of time at current address. Now, as any public health expert will tell you, there's a lot of factors to go into that But to me, that's a really interesting finding, taken together, that we can see both very specific responses to specific medications. We can also see responses to more general medications and look at causation there. And then with things where we have an uncertain sort of environmentally influenced etiology, we can start looking at features that may affect these sorts of things. And that to me is really exciting, that we're starting to be able to look at really sort of specific things, sensitivity to particular medications, as well as large scale environmental exposure. So that's something that I find really exciting, and I hope you do too. I personally can't wait really for the community writ large to start digging into questions like this with large scale data sets like the UK.